Hello and welcome to another TD channel video. On this video we're gonna go ahead and continue developing our MDD reader plugin, and right now what we're gonna do is we're gonna go ahead and implement the actual deformation of the points in the plugin. So far we have created all the different attributes that the plugin is gonna need for us to control things, but now we're gonna go ahead and actually do the deformation. So let's get started. So this is what we had before, if you guys can remember, and here under the class TDC MDD read, which inherits from npx deformer node, we had the form method, but we had not implemented anything. Basically all it said was pass. So we're going to go ahead and delete this line, and we're going to start adding some of the things that we need to do. Well, the first thing we need to do is go ahead and capture all the necessary data from the plugin attributes. So first thing we're going to do is capture the file handle, which basically is going to tell you which file you're going to read. So we're going to do file handle equals data block dot input value, and then we're going to do self.mdd file. Then we're going to do file value, and this is going to be equals to file handle dot as string. It is a string because we're trying to get the file path. Next we're going to do the time handle. This is going to be equals to data block input value self.time, and then we're going to do time value equals time handle dot as int. Next, offset handle, and this is going to be data block dot input value self dot offset, and then offset value equals offset handle as integer. And now here I'm going to do times -1, which basically is going to invert the value. The reason I do this is because when I was developing the plugin, I realized that as I was adding a positive offset, it would move the animation backwards. So I didn't really dig in too deep into why this was happening. All I know is that I could fix it with a very simple multiply -1, so I did it, and that's why we're doing it right now. You guys will see this how it works pretty soon. Then the last one we need to capture is cycle handle, and this is going to be data block dot input value self dot cycle, and then have a typo over here, so let me get rid of that. Data block into cycle, then we're going to do cycle value equals cycle handle dot as bool, and basically because we want it as a boolean. So what we've done in all on all of these lines, basically first we get a handle to the data block that we need to extract the data from. So basically this data block contains a whole bunch of attributes that belong to the plugin, and you are telling it, give me the input value. For example, on this line, give me the input value that is using the self.mdd file internal object. So if you go up here, you see we have a whole bunch of objects that belong to the class. We have time, offset, cycle, and MDD file. And these guys, when we were creating, when we were initializing the node, we were pretty much populating each one of these guys with an attribute. So that's what you do here. You go into the data block and you tell it, give me this attribute that is connected to MDD file, for example, on this line. Give me the input value, and then you have to tell it how you want to read that value. So for file value, we want it as a string, then we want it as an integer, another integer down here, and then finally we want a boolean. So once we've done that, now we're going to go ahead and implement pretty much what would pretty much be the deformation. So we're going to do if file value is not equals to empty. So basically, if there is a file that has been assigned, because you don't want to run through all this deformation if there's no file, there's no data to read, we're going to do frame equals self dot load data file value time value offset value and cycle value. So we have used all of the different values that we had gathered beforehand. What is this self.loadData? You're going to see very soon. It's going to be an internal method for our class. So next we're going to do while geom_iter dot is done is equals to false. Then we're going to go ahead and get a point from this self.data deltas frame geom_iter dot index. Then we're going to prepare a geom_iter dot set position. Then finally geom_iter dot next. So this is pretty much all we need to do for the deform method, and the trick here is that we are getting the information on the self.load data, which we're going to implement pretty soon. But basically this geom_iter parameter that's being passed to the function, this right here, is an iterator over your geometry point. So what you're doing here is like the first time it evaluates, it knows that the current position of your geometry iterator is 0 because you have not iterated through it yet. So the first time it goes around, you're going to ask it, geometry iteration, is it done yet? And then it's going to tell you no, because you're probably at the first position of that of all your points. So it's going to give you false. So you're going to go in there, and then we're going to use this self.deltas dictionary to be able to capture the new point the new position where we want to move the point. And for that, we're going to use geom_iter.index. And basically, this is going to give you the index of the current point in this iteration object. So once you get that point, which is established here by is stored in pp, then you go ahead and you do geom_iter. That class has this one function called set position. So you're going to go ahead and just give it the new position, which is going to be pp. And then finally, you're going to tell it, okay, geometry iterator, go ahead and jump to the next point in the list of points. And then it's going to start over. So this is going to keep going on until you reach the last point, at which point geom_iter is going to return, is going to return equals true. So with this done, now what we have to do is go ahead and implement our load data. So def load data, and we're going to put self first, and then we are going to go ahead and pass to it, we're going to do file name, frame, offset, and cycle. So for now I'm going to put pass in here, basically because first I need to add in here more class members that we're going to need to use inside our script. So for instance, one that we were using for a while was the deltas. So I'm going to have to add that in here. So let's start adding all the different ones we need. So first we're going to need self.mdd file val, which is going to be the name of the file that we're trying to read. Then self.frames, the number of frames to read. Self.points, the number of points that we're going to be dealing with. Self.times, the times that are stored in the MDD file. Self.deltas, which is the position for every point at a particular frame in your animation, in your cache. So self.deltas, we're also going to initialize this to none. And then finally self.file handle, which is going to be an actual file object, so none. So we can go over here and do this. Try to clean things up a little bit. Okay, I screwed that one up, that one too. Okay, so with that being done, we're going to go ahead now and implement. So the first thing we want to do is make sure that we only read the header the first time we open the file. So basically we're going to add here some information that's going to allow us to just read the header once. So we're going to do if not self dot file handle, and file name is not equals to self dot MDD file val. We're going to do self dot deltas. We're going to initialize to an empty dictionary. Self dot MDD file val is going to be equals to file name. Then self dot file handle. We're going to go ahead and open the file, so file name. But we're going to use this special code, which is RB, which means read binary, because the data is stored in binary format. So now we're going to go ahead and initialize frames and self.points by using the unpack command. So we're going to put this here, and then we do this to I, and I'll explain what this means very soon. And actually, before we use pack, let me make sure that we're using it up here. Okay, I don't have it listed, so I'm going to go ahead and put it in here. We're going to do from struct import unpack. And unpack is a module that allows you to get binary data out of either a socket stream or a file stream or whatever. As long as it's a stream of binary data that's coming in, you should be able to unpack it into what you need. So what this tells, the unpack command, it tells the greater than lets it know that what you're going to be dealing with big endian binary data. Remember on the first video we talked that that's what MDD file format uses. So it's going to allow you to read big endian. The next character, this 2 right here, you're telling how many different values it needs to interpret. And the last one is which kind of value it's going to interpret. So basically what this is telling it is I'm going to be reading from big endian to integers. That's what the 2i means. You can read the unpack documentation to read all the different formatting options, but this is how you would get 2 integers. And that's why over here you see we're going to be unpacking into 2 variables, which are pretty much going to be 2 integers. So the next part of the unpack command is basically where you tell it how much data to read. So you're going to give it the file handle, self.filehandle.read, and you're going to tell it to read 8 bytes. Why 8 bytes? Because we know that each integer uses 4 bytes. So since we're reading 2 of them, as you can see right here, we need to tell the system to read 8 bytes. So where does this read from? Basically, it's gonna when you start doing a read, it's gonna start at the first position of your file stream because you have not done any reads yet. So this line right here is gonna read from position 0 to position 8, which is actually the 7th one. So that's what it's gonna read. So now we're gonna go down here and we're gonna do self.times, for which we're gonna unpack, and then we're going to use a format operator to figure out exactly how many elements we need to unpack. So we're going to do self.frames, and then we're going to do self.filehandle self.frames times 4. Okay, so if you remember the file format in our previous, in the first video where we discussed the file format, the first 4 blocks were going to be frames, the second 4 blocks were going to be points, and then you were going to have this long block that represented the times that were stored. And basically what we're doing here is we're using our Python format operator to be able to replace this $D by the number of frames. This is something that we don't know ahead of time. We will only get it by extracting things. So we're going to do extract X number of frames. So let's say we're going to extract 10 frames. So this is going to be 10F. Why F? Because we're extracting a float. If you remember properly, self-times, the times on the MDD file format are floats. And then what we do is we tell the file handle to go ahead and .read, I forgot here, to read how much data do we want to read? We want to read the number of frames. Let's say, once again, it's 10 times 4. Why times 4? Because a float uses 4 bytes. So we're going to read 40 bytes. Where does this going to read from? It's going to read from position 8, which is the last place it was when we did this read, to position 48, because we're reading 40 different steps. So now we have the times. Now the next thing we're going to do is figure out what the current frame that we're going to read needs to be. So we're going to go in here and we're going to extend this, and we're going to do if self file handle and not self file handle dot closed. So what this does, it makes sure that we only go in here if we indeed have a file handle and if that file handle has not been closed. So through this whole process, we're going to keep an open socket to our file so that we can, as you move the slider around, things update as fast as we can make them probably. So once we're in here, we're going to declare a quick convenience variable called header offset. And this is going to be 8 plus self.frames times 4. So as you can see here, we're storing here the offset of this 8 bytes that we read here and this number of bytes that we read here. So if that was 10, we're reading, this would be 48 and this would be another 8 over here. So that's what we're storing, because we're going to need this value to determine where we're going to read from. Next thing, let me get out of this. We're going to do if cycle. So basically the user decided that they want the animation to cycle. We're going to do frame equals to frame plus offset. And then we're going to do a modulus operation by the number of frames. So what does the modulus operation do? It basically gives you the remainder of a division as an integer. Like for example, if you divide a certain number by another one, if you're not getting a perfect integer return value, you're going to have a remainder, and that's what this does. So for example, if we had an animation that's from 0 to 10 and you were telling it give me frame 0, it will return 0. If you tell it that you want the value of 5, it will return 5. But if you tell it I want the modulus, let's say we're trying to read frame 10, and you do the modulus of 10 by 10, that's going to return 0 because it's perfectly divisible and there's no remainder. Once again, if you go to 15, if you divide those two, you're going to have a remainder of 5. So basically this allows you to loop things. So 15 is going to be 5, 22 is going to be 2, 38 is going to be 8 if you're doing modulus of 10. So that's what this does. Then what we can do is else. So if cycle has not been set, we're going to do frame is equals to frame plus offset, and then we're going to do a couple of logic here just to make sure that we don't overrun the size of our array. So we're going to do if frame is greater than self.frames, we're going to do frame equals self.frames. If frame is less than 1, frame is going to be equals to 1. So this is going to make sure that the frame number is always something that is inside the boundaries of how big our array is. And then once this is done, we're gonna go ahead and move the cursor position to the right location. So if you remember the current position of the cursor on this file read object over here, at this point the current location, it's 48 plus 8. So we need to make a little offset to make sure that we set it to where we need it to be, and we do that with a command called self.filehandle.seek, and you need to give it the position where you want to go. So we're going to do header offset, which is going to count for a header, and then we're going to do plus frame times 12 times self.points. So why do we do this? We're basically header offset is going to move us forward, just to make sure that we don't interfere with the offset. Frame, we've already dealt with the frame over here, so frame is going to move us pretty much to the position of the frame. So let's say frame is 10. This is going to make sure that we move the current cursor to the right location. So we're going to do frame times 12. Why are we doing times 12? Because we are trying to read 3 float values that represent X, Y, and Z of the position. And each one of those values, there are 3 floats, and each float is 4 bytes. So it's 3 times 4 equals 12. And then times the number of points. So what this is going to do is it's going to make sure, like I said, let's say you're trying to read frame 10. It's going to make sure that the seek position is equals to 10 times 12 times whatever number of points your mesh has. So this is going to move the seek location way far into the array, or way early into the array if it's 0. Let's say you're reading frame 1, so it's going to be 1 times 12 times the number of points. So once the position of the cursor has been set, we can go ahead and initialize an array, a list called point list, and then we're going to do for pp in range self.points, and in here we're going to do point vals. So we're going to extract the point values directly. Is going to be unpack. We want big endian, 3 floats. That's what we need. And we're going to say, 3 floats. And then we're going to do self.filehandle read 12. Because we only need to read, 12 bytes because we're reading 3 floats. Next, we're going to create a Maya point object. So we're going to do openmaya.mPoint, and you can initialize this with 3 float values. So we're going to do point vals 0, point vals 1, and point vals 2. Right? So that's going to go ahead and create this new variable. And then finally what we're going to do is we're going to store this on the point list. So we're going to do point list.append point. So we're putting that in the list. Once we're done iterating through all the points in the mesh, we're going to go ahead and store this in the deltas dictionary. So we're going to do deltas. Let me make sure I'm properly indented. Self.deltas frame, and that's what we're going to use as a key, is equals to point list. So basically now the deltas, if you tell it, hey deltas, give me whatever you have stored on key 0, is going to give you a list with all the positions that we extracted from our MDD file. And then finally what we're going to do is return frame, which is the frame that we were dealing with. So we're going to dedent that. So hopefully that will make things a little bit clearer as we're using it down here. So here we are passing, file value, time value, offset value, and cycle value. And this thing is going to get computed. The self.delta's internal object of the internal member of the class is going to be updated, and it's going to return just the frame value. Because, you know, the frame could be a different value based on whether we're cycling or not, so it's going to return that frame value. So we capture it here, and then all we're doing is we're telling, okay, deltas, give me this frame value that you returned, use it as a key, and give me that complete, from that list right here, give me whatever stored in the current index. And that's all you have to do. So at this point, we pretty much have our script ready. All we have to do is start testing it, and we're gonna go ahead and do that in the next video because this one's starting to run a little bit long. So thank you so much, and I'll see you guys soon as we start testing this plugin.